This is another practice problem for graphing functions, specifically absolute value functions. Now before we get started, you'll notice I named this function g of x. I did that to differentiate it from the last function I did, which I called f of x. It's basically just like colored key change to tell them apart. There's no difference. It's just to keep them apart so I don't get them confused and call them both f of x. Okay, so this function when they want us to graph is g of x equals negative 2 times the absolute value of x plus 1 minus 4. So the first thing I have to determine is what the parent function is for this, and this is clearly an absolute value function again. So the parent function would be g of x equals the absolute value of x. So I write down my parent points, which are the same as on the last problem. So the one thing that makes this problem a little bit more challenging than the last one is that there's a few more transformations. But again, we got to follow the PEMDAS when we go to find these transformations. So let's go inside the absolute value to start. So we have x plus 1 inside. So that's going to shift the entire graph to the left, 1. All right, now we move to the outside, so there's nothing left to do inside. And order of operations says we have to take care of multiplication. There's actually two things being multiplied here, the negative and the 2. Both of them have a different effect on the graph. Let's start with the negative. The negative out front is going to change the y-coordinate. So it's going to, if it was positive 2, become negative 2. If it was negative 3, it'd become positive 3. So what the effect that has is that it's going to reflect the entire graph over the x-axis. The 2 out front is going to cause a vertical stretch to the graph. And it doesn't really matter what order I do those two in because they're both multiplication. And the last transformation on this is minus 4 out back, which is going to take the whole graph down 4. So now the last thing to do is figure out the transformation, how it's going to affect my parent points. So left 1, again, it's the opposite on the inside, so that's going to move the whole graph to the left 1, so it's x minus 1. I'm going to subtract 1 from all the x's of the parent points. Now, you'll notice for the y, all I have to do is take everything that's being done to the absolute value. So it's negative 2 times the absolute value, then minus 4. So to the y, I just do negative 2 times y minus 4. Basically, the y is the absolute value. So doing that, subtracting 1 from all the x's, 1 minus 1 is 0, 0 minus 1 is negative 1, negative 1 minus 1 is negative 2. Negative 2 times 1 is negative 2, minus 4 is negative 6, negative 2 times 0 is 0, minus 4 is negative 4, and of course the symmetry. So if you're really careful, you can actually skip the last calculation with the parent point because you know it's got to have that symmetry, so it's going to have the same y-coordinate as the first y-coordinate you plugged in. But be careful if you mess that up and you just take the shortcut and you get it wrong, you're not going to notice it. So again, the last thing now that I have the points, is just to plot them and finish graphing the absolute value. I look at it, it's a V. You can see it's been reflected. You can see it move left 1, and you can see it move down 4. The vertical stretch might be a little bit harder to see, but if you compare it to the parent graph, you would notice that it's a bit narrower.